In diffraction grading, it's the same thing, sort of a young double slit experiment. We have already talked about this. But here, what we are doing, we are making it a sort of blind here. Now, blind means we are just having small slits here, and we are passing a monochromatic light from these small slits. And that's what we called diffraction grading. You can simply think of it like, let's suppose this is a sort of sheet here, glass sheet or whatever. We are putting a very small slits like this, Mike. And what we are doing, why we are doing it, because light has to pass through. So we are making a glass sheet as a blind here, so that light will come, but with a less intensity. So we are making it a uh, sort of a blind here. So a diffraction grating is a plate on which there is a very large number of parallel, identical, closely spaced slits. So previously we were talked about young double slit. It was just a one slit. Let me just show you. Yeah, sorry, it's a different one. So previously we were talking about just two slits. Here we are talking about multiple slits. That's what we called as in a sort of a plate in which we have very large number of parallel, identical, closely spaced slits, right? So that's what we called as diffraction grating. When monochromatic light is incident on a grating, a pattern of narrow, bright fringes is obtained on the screen. So basically, what happened when a laser light is passing through, these small fringes, so you can see here, you will get the pattern same as you are getting the pattern in young double slit experiment. But these patterns are, you can say, less bright and narrow bright fringes. Narrow bright fringes means that definitely the intensity of the bright fringes are being less than. Now, at which the maximum of the intensity, the constructive interference are produced can be deduced by the diffraction grading equation. Now, here, the diffraction grading equation is the same as we have done previously. D sine theta is equal to n lambda, where n is equal to 0 is right at the center of the screen, which is here. And this is always a bright fringe. This formula we have also done in young modulus. The formula will remain the same. No difference at all. D is the distance between the slits. So you can, yeah, distance between the adjacent slits, like distance between this and this slit is D, and lambda is the wavelength of a source, and angular separation of the order of maximum orders. This theta means the angle between each and every line which is passing through each slit. All right. Now, only difference in this particular case is that here, if you want to find out the number of line rules on that particular glass, you can find out as D is equal to 1 upon N, or N is equal to 1 upon D. You can say, sometimes state that lines per meter on the grid, which is represented by the symbol N, and D can be calculated from number used the grading. So, for example, if in a big glass you have total number of lines, let's suppose 1 upon 10, then basically the distance between each slit is 0.1, right? So this is the extra formula here, because here there are multiple small slits here. So number of ends means number of slits technically. So D is the distance between each slit. So you can simply reverse it and you will find the value small d. Okay. Now the second point, which is very important in that, is angular separation. Now, angular separation, as the name suggests, is the angle between each and every line which are actually going at different angles with respect to n is equal to 0 or with respect to the origin. So angular spacing of each maxima is calculated by rearranging the gradient equation to make theta the subject, and the theta is taken from the center, meaning the higher order are the greatest angle. What is the higher order angle, by the way? Yes, girls. Highest order
Theta
will be,
three.
it will be, if you check it out, it will be angle is equal to 90-degree. Slit and this one, the angle will be 90-degree. And other than that, all the angles are at different angles. Okay. Let's check it out. You will be further shown this. So angular separation between two angles is found by subtracting the smaller angle from the larger angle. So angular separation between the first and the second maxima is theta 2 minus theta 1. So that is the separation between the two, you can say, between two orders, right? So here the difference is angle as well. Now check this out. The maximum angle to see order of maxima is when the beam is at right angle triangle to the diffraction grading. This means theta angle will be 90 degrees. Because the formula is basically d theta, d theta is equal to d sin theta is equal to n lambda. So when you will get the maximum angular diffraction, when this theta value will be 90 degree, because sine 90 is equal to 1. So it means that the angle should be 90 degree with respect to the origin. This will be the point where you will get the maximum angular to see the order of the fringe. Okay. So the maximum angle to see order of the maxima is when the beam is at right angle triangle. It means that at n is equal to 0, your angle is basically 90 degrees. And at this one, you will have the maximum diffraction grading at this point. Okay. So the highest order of maximum visible is therefore calculated by the equation. Now check this out, which I really wanted to show you. N is equal to d upon lambda. Very simple, because sine 90 is gone. So n is equal to d divided by lambda. So n must be integer. Now this is important, that your n should be integer. So if the value is in decimal, it must be rounded down. What is mean by rounded down? It means that if your value
It just
It means that if your value
if
comes to 0.7, let's suppose, so you will not round it to 3, but you will round it to 2, 1 less, because zero point 0.7 will not be calculated. The answer will be in a whole number. That's what it means. All right.
yeah.
Now let's see the numerical here. The formula is n lambda is equal to d sin theta. And for d value, you will have 1 upon n as well. Now check it out. They say an experiment was set up to investigate the light passing through a diffraction grating with a slit spacing of 1.7 micrometer. The fringe pattern was observed on a screen. The wavelength is 550. Now let's do that. The slit spacing of 1.7 micro d. This is the small d given as 1.7 into 10 raised to the power minus 6 meters. And the fringe pattern was observed on the screen. The wavelength is given 550 into 10 raised to the power minus 9 meters. What they are asking, this is the diagram they have just shown in. They say calculate the angle alpha between the two second order lines. Between the two second order lines. So how will you find out the angle between the two second order lines? The formula will be d sine theta is equal to n lambda. You have to find the theta. Can you do this question, please?
Okay.
I'm getting
38 is,
38.4.
yeah. See, 38 is one angle, but they are also asking for beta as well. So this angle plus this angle, or you will multiply it by 2. So what is it?
Will you multiply by 2?
Yeah, the reason is one angle is here at the top and the other angle is here. Both are second. One is from the center to the top and one is from center to the bottom. They are actually asking you the total angle. Calculate the angle between alpha between the two second order lines. If it's alpha, then it will
It's
be.
76.8.
Let's see. Let's check it out. See, you use the formula. This is the value you got. But why they are getting 40.54? Your angle is different.
Yeah, I got 38.
but this is 40.54. Did you put a different values or what? Okay, maybe they rounded off to two decimal place, right? So this is one angle, right? Now see what
Oh
they
no, it
did.
says at the top. They did. I don't know.
No, no, your calculation. Maybe you took some extra values. They took just two decimal
Maybe.
places. That's fine, no issues. One or two numbers, because you took more values, they took two decimal places only. So see, in the end, they multiplied by two. Yes, Alicia and Mahnur, any problem in this numerical?
I got
No, sir.
40.3
He
for
got,
step 4.
yeah. And then
So
you have
then
to
times
multiply.
2 should be 80. I got 81.
So Alicia, you got different angle. Check it out why your calculator gives you a different value. If I ask you how many lines are ruled on the glass, on the same glass, how will you find out? Slits are given. So you can simply do n is equal to 1 upon d. So this is 1 divided by 1.7 into 10 raised to power minus 6. Can you find out what are the numbers? What is the number?
Um, 588,235.
I think you better tell me in some 10 raised to power. It will be easier to understand.
Uh, I'll just say each digit one by one.
No.
588,235.1.
Okay, that's fine. But that point one, it needs to be neglected. So these will be the total number of lines on your glass if you really want to find out the total numbers. Okay. So technically speaking, the formula is same, but the understanding of the formula is a bit different. Here, the theta means the angular displacement or angular uh, angular displacement with respect to the central point. D will be the slit size, and only thing is the number of lines on each glass will be equal to total number one upon total number of slits. Okay, understood?
Yeah.
Very simple actually. It wasn't that difficult. Now let me see if it's finished here. Then we will move further. And I think so. It's take care of the theta. Now a small derivation. It's the same derivation which we have done for the young double slit experiment. Not a single thing is different in that. Absolutely same. So what they are saying is, I just quickly go through that. They say when a light passes through a slit of diffraction grading, the path difference at 0th order maximum is 0. Like this one is absolutely 0 as we have done for the young double slit. But any other one, path difference will has to come from here. So we draw a straight line from that point, and that point will be your theta then, and that point will be your, I mean, sine theta will be equal to opposite divided by this base. So technically speaking, this is your n lambda. For the time being, we are believing because this is a constructive interference, so we say that distance is lambda, whole number. It can be 2 lambda, it can be 3 lambda. Let's take it as n lambda. So the formula will be sine theta is equal to n lambda divided by d, right? Now, if you want to find out the lambda value or n lambda will be equal to d sine theta. So this is the same formula as we have derived for the Young modulus. Not a single thing is different. Where theta is the angle between the normal and the maxima, lambda is the wavelength, and d is the separation, right? So basically, this is the thing. Now, if there are different thetas, the value will be different as well. For sine theta 2, your n value will be 2. For sine theta n, your value will be different. So technically speaking, it will be sine theta n equal to n lambda d. This is the formula. Because for every single bright fringe of order n, there will be a different sign. So technically, here in this case, the formula will be d sine theta n is equal to n lambda. So here for
I,
each per, yeah, you're saying something?
I just have a question. The question we just did said to find the angle between two second order um
Fringes,
angles,
fringes.
fringes. What if it says to find the angle between uh, a first order
But there cannot be
fringe
first.
and a third
See,
order fringe?
listen. Yeah, if it's like this, then you have to find out the odd. You're absolutely very good question actually. It simple mean is, let's check it out. If you just say it, for example, because we know that actually this angle what we are finding out is actually with respect to the zeroth fringe, right? So if, for example, let's suppose this is your line for the third fringe, then this will be the angle, right? And
Mm,
same thing, you're saying that angle between the first and the third one, right? That's what you said.
yes.
So find out the angle between the first and the central one, which is this one. Now, how will you find out angle between these two? Subtract the two angles and you will get the angle between the first and the third one.
Okay.
Because for the first one, the angle will be smaller. For third one, angle will be greater. If you subtract these two, you will find the angle between the first and the third fringe. All right?
Okay. Yeah.
Yes, Manur and Alicia. Any questions?
No.
No, sir.
Very simple topic. Only difference is here for every angle you will have n lambda value. Lambda will be remain constant, but the angle will be different. All right. Now let's move further. But before we go further, uh, there is one topic actually which is left in the previous one, which I will have to tell you right now here at this point, which is basically what is that thing? That is called the intensity. Where is it? Equation of, yeah, that is the one actually I had to talk about. Now, this is very important topic. In young modulus, first of all, quickly, in young modulus experiment, what we are actually proving, not we actually, Huygens proves that the light is a wave, right? So he actually proved, previously it was Newton who said that light is an object, but he proved that light is a wave technically. So now actually he find out two different formulas. One formula is the distance between two fringes or fringe spacing formula, and one formula is for the there is another formula in the form of d lambda. I forgot the name of the formula, but other than that, there is another formula because what he said it that a fringe which develop at the center is more brighter. As he said, the angle, the phase difference between the two waves are zero. That's the reason it's more intense radiation, and then the intensity goes reduced and reduced and reduced. We have talked about this that intensity technically means more amplitude. If amplitude is more, intensity of a wave is more. It is nothing to do with the frequency. Pitch is everything to do with the frequency. So now, equation of intensity of the radiation. In progressive wave transfer energy, we know that. So amount of energy passing through a unit area per unit time is the intensity of the wave. So what exactly is the intensity? Is the energy passing through unit area per unit time. Energy passing in a per unit area per unit time is the intensity of light, which is given by this formula. I is equal to power divided by the area. But remember that that power they are talking about is power in watts. So technically speaking, the SI unit for the intensity of light is watt per meter square. This is the intensity formula, guys. Please remember this formula. Now, a very interesting fact about these things. The area the wave passing through is perpendicular to the direction of velocity. Now remember that the area should always be perpendicular, because the area, if not perpendicular, no wave will be passed through. The intensity of a progressive wave is also proportional to its amplitude square and frequency square. Now this is another thing. Intensity is directly proportional to the amplitude square of the amplitude, and the square of the frequency. Now, out of these two, technically speaking, your frequency is kept constant. So one thing is the point, which is amplitude here. So intensity W meter per second square is directly proportional to the amplitude, and it is the square, and directly proportional to the frequency square. Right? So this is the formula. Now let's see further what the formula will be. This means that frequency or the amplitude is double, the intensity increased by the factor 4. Any problem in this?
No.
No.
Everyone? Mahnur?
No, sir.
Okay. Now, spherical wave. What do you mean by spherical wave? Spherical wave are wave which actually pass through a certain area in sort of a sphere, in sort of a spherical, like sort of a circle, like this you can see here. They are not passing in a straight line, but they are passing in a sort of a circle. So a spherical wave is a wave from a point source that spread out equally in all the direction, right? The area the wave passes through is surface area of a sphere, that is 4 pi r square. Now, because they are passing in each and every direction, so we believe that it's a sphere. And a sphere, a circular area is, or total surface area is 4 pi r square. Now we know that the formula we already have is I is equal to P upon area. So instead of area, you can put it as I is equal to P divided by 4 pi. So the formula is changed for the intensity of surface of a sphere. Intensity at surface of the sphere. This is a separate formula for a separate entity, right? Okay. Next, the energy twice as far from the source in the spread over 4 times in the area, hence 1/10 the intensity. So technically speaking, if radius increased by double, intensity reduced by 4 times. So radius, if you are far away, then its spreading is less. So radius should be as small as possible, as per the formula. Okay. Now, assuming there is no absorption of the energy, the intensity decrease with the increase in the distance from the source. Same thing as I just told you, if you increase the radius, the intensity reduces. Note that the intensity is directly proportional to the 1 upon r square. It's actually directly proportional to the 1 upon r square, but inversely proportional to r square. This means when source is twice as far away, the intensity is 4 times less. And 1 upon r square relationship known as in physics is inverse square law. Okay. Any problem in this?
No.
Can you go over inverse square law a bit again?
It's simple that if you see the formula, well, this formula, check this out. Can I say that intensity of the wave is inversely proportional to r square? Am I right?
Yeah.
But same thing, I can say that intensity of the wave is directly proportional to 1 upon r square. I'm not saying r square. I'm saying 1 upon r square. This is what we call as inverse radius. I mean inverse distance law. Okay, inverse square law. Rather than we are talking about radius, we are talking about 1 upon radius square. This was a small topic that was left. There are one more topic actually left with that, but let's move forward because I just want to go forward and then I'll come back. But do you understand that basically this is the formula?
Yes.
Good. Okay, they say that there is something. They say intensity of a progressive wave is proportional to the square of the amplitude of the wave, and it is also proportional to the square of the frequency. The variation with the time t of a displacement x of a particle when two progressive wave q and p pass separately through the medium. Intensity of wave q is I naught. What is the intensity of p? What is the formula? Can you use the formula to find out the intensity in the form of these alphabets x naught and all this? Let me just show you. This is the formula you have to use. Intensity is directly proportional to a square and directly proportional to f square. So calculate how much the amplitude has increased. What you will do here, you will simply apply a formula that is AP is equal to 1 upon 2 square AQ. So wave P is equal to 1 upon 4 of I naught. Now, why this is the formula? Why AP is equal to 1 upon 2 square R? This is the same thing we were talking about, this 1 upon R thing. R is not the radius in that case. It's just the amplitude, you can say. Check it out. For AP, this one, the distance is, amplitude is this distance, which is 2. So the formula will be 1 upon 2 square AQ. Why 1 upon 2 square? Because here the amplitude reduces to 1. There the amplitude reduces to 2. I mean increase. So basically wave P has 1 upon 4 I naught. So basically intensity of P is 1 upon 4 the intensity of I naught. I naught is greater because their displacement is greater.
I'm having a tough time understanding this.
You do not understand or problem?
I'm not understanding
Okay.
how did you conclude that.
See. See, they already found out I naught here. They said this is I naught. Now, first important point is this is 2 and here the amplitude is 1, right? We already know that the formula is S amplitude square, right? So intensity is directly proportional to amplitude square. If I place 2 here, it will become 4. If I place amplitude 1 here, it will be basically square. So basically, frequency of both the waves are same. Frequency is no difference. Only difference is amplitude. So which one is greater by whom and how much? P1 is actually greater, I mean intensity wise, and this one is also this one. If I talk about this, let's suppose IP and this is IQ. IQ is lesser and IP is greater. My question is how much? If IP value is IP, IQ value is 1 upon 4 times. Because this formula is saying that amplitude square comes as 4, while when you put 1 here, the amplitude square comes as 1. It means that intensity in case of this one is 4, and in this one it's 1. So how do I write it? I can write it as AP, which is this one, is equal to, because this one is already 4, so it will be 1 upon 2 square times AQ. This is about the amplitude. So we know that if amplitude is like this, the intensity will be the square of it. So basically here it's 1, here it's 4. So it will be 1 upon 4 I naught. Zoha, now you
For the
understand, or is still problem?
frequency?
No, no, this is
Now it's better.
so basically, I'm just checking the formula on. If you place the values in the formula, you will understand that. For the first one, the amplitude is 2x naught, right? Forget about x naught, it's 2. So when you square it, it means that I is directly proportional to 4 value. On the other side, if you place 1 there, so amplitude is 1, or you can say intensity is equal to 1 there. So this intensity is 4 times the intensity for Q. Now, how to say that intensity of P is related to Q? You can simply say that intensity of P is 1 upon 4 times the intensity of Q. No, sorry, intensity of P is 1 upon 4 times the intensity of Q. Or in other words, intensity of Q will be 4 AP.
I think I will really understand if I just say a question that's not like this one
No problem. It's just to
with
understand.
values.
Yeah, this is just to make you understand the things. This is nothing to do with a question. This is just for understanding that amplitude is there to actually manipulate the things. This is Q and that is P. This one, the second one is smaller. This one is bigger. Now you tell me how much smaller is this one and how much greater this one is. This is 4. This is technically the value should be like that. It should be 4 I naught and that should be I naught. If I give you a question like this, because intensity of Q is 4 I naught and this one should be I naught. But instead of that, they give you this I naught. So this one is definitely 1 by 4 I naught because that one is smaller on the right hand side. That's what they wrote it in the form of equation. I want you to copy this and see go through this question once the class will over. I hope you will understand that. That's not a problem thing, but once you have to go through that, you will understand it. It's not a proper question. It's just to make you understand that intensity is directly proportional to the amplitude square. So two waves are given, and you can simply judge which wave has a greater intensity. By the way, which wave has a greater intensity, Q or P?
Q
How much greater?
by
Four
2
times?
times.
No, by 2 square times because I says amplitude square. Okay. So that's what the trick here is. If this is 2 square times, as you just said it, so it means that its intensity is 2 square while its intensity is 1 square. Or you can say its intensity is 4, its intensity is 1. Now you tell me if the intensity is given as I naught, what will be the intensity of P? If I naught is equal
Um,
to 4, what is the intensity of P naught?
1 over 4.
1 over 4. Now place instead of 4, I can place I naught. Can I? Because that's what the question says.
Yeah.
So that's what I was telling you. It's 1 upon 4 of
Oh,
I naught.
okay.
Now do
Now
you
I
understand?
understand.
And you, Manur and
Yes.
Alicia,
Yeah.
same thing happened because frequency is also there. Now frequency increased or decreased, it means that frequency will be 2 square times of Q. See here. Here the frequency will be doubled as well because it's greater. So this is P, its frequency will be square of 2. Check it out. So you multiply it by 2 will get the frequency of P. So wave P is equal to 4 I naught of Q naught. So basically, when you substitute all the values, you will get intensity of Q is equal to I naught. It will be the same intensity your Q has. Why? Because now check this out, very interesting. If technically speaking, because the formula is like this, check it out. Intensity is directly proportional to A square. and intensity is directly proportional to F square. What about these two? In amplitude and frequency, what will be the relationship? Amplitude and frequency. Amplitude and frequency are inversely proportional. So if amplitude increases, frequency reduces. That is the thing. They say wave P is a double the frequency of wave Q. Amplitude of Q is 4 times of P, but the wavelength will be doubled. So you can simply place Fp is equal to 2 times of Fq. So very simple. P is equal to 4I naught. Now, technically speaking, when you place the values here, it says I naught directly proportional to F square A square. Then when you place the values here, you will see yourself that it will come as 1 upon 4, 4 I naught. So these two will cancel, and technically speaking, both P and Q got the same intensity. Why? In one, the amplitude is 4 times. In other, the frequency is 4 times. So both will cancel the effect of each other, and you will get the intensity equal to the same. P intensity is equal to Q intensity, which is I naught. All right.
Yeah.
Okay. What have we studied in this particular phase? There are two things we study. First thing is we have seen a formula for I intensity, which is power upon area. This is the intensity of the waveform, where power is equal to watts per meter square. You can say power passing through certain area is called as intensity. Then we have seen spherical wave which are going everywhere, so it will be watts divided by 4 pi r square. Now this tells you a different story. They said that intensity is directly proportional to 1 upon r square. So if radius or distance increases, technically, the intensity reduces, right? So we give it a name called inverse square law, which is I directly proportional to 1 upon r square. Then we have seen a different ball game that I is directly proportional to amplitude square and I is directly proportional to frequency square. But we have seen another thing as well, that amplitude and frequency are inversely related. So if amplitude increases, technically speaking, your frequency reduces because nothing is constant we are taking here. So technically speaking, as the amplitude increases, the frequency reduces. So actually they are cancelling the effect of each other. So that is the case in this question we have seen. But this is the formula we have to take through. Right?
Yeah.
Okay. Now let's start testing ourselves and let's see what happens. Let's test ourselves. What is the test here? Let me rub that and let's do some of the question related to this. They say which row of the table shows the base unit of its base SI unit, which way? Base quantity and its base SI unit. The base SI unit means before it will be given by any name, what will be the unit, the base unit. Let's see what they are offering. Which one is a base unit?
A,
Yeah. Charge
B,
is C, length is
C. Wait, aren't they all D?
D,
I don't
temperature.
know. They all are.
What about mass? What about length?
They're all correct.
They are all correct. Let's see.
Except temperature. Temperature should be in kelvins.
Yeah, but let's select any one of that. If you have to select what have to be, let's see. A is incorrect as C is not a base unit. B are they saying length. Remember that the very basic unit is meters. G is not the base unit because it's in grams. Charge is C. Charge is not C actually. That should be coulombs. It should be mentioned here. Temperature is centigrade, but the actual unit is Kelvin. The only unit which is correct here is the length meters. The quantities are right, but the units are wrong. Okay. Which row of the table shows a combination that will produce a real image? We didn't see this, so leave that for the timing. This is diopter. We have didn't see that critical angle. Okay. Why they give you this? Okay.
We
Let's
went through polarization.
yeah, no, this one is different. We didn't do this. This is related to the lens and everything. We will do that later on. But first, because I have to tell you the wave nature, I mean, not the wave nature, the other one. So that's the reason actually I just came across that. Okay, let's come back to the business where we were actually. Uh, we were here actually. Why am there? Wait a minute. Now the topic is basically photoelectric effect, which I have to actually jump on. And for that reason, let's quickly talk about the light. Now, very interesting factors. Diffraction we have done, diffraction grading we have done it. So this is all what we have wave nature we were talking about. Now, another very interesting fact is a de Broglie wave equation. Now, what is de Broglie wave equation saying? De Broglie wave equation is here as well with me. Wait a minute, what is it? Now, what de Broglie is saying, let's see. De Broglie is very interesting, and you know what he says? He said actually he just gave it an equation related to the wave. Now, what exactly it is? Okay. Now, wave nature. The wave nature of a matter is one of the most counter intuitive concept in the wave. And we have seen example of both the particle nature of a light and wave nature of light. So we have already seen that in one experiment, it behaves as an object. In one experiment, it behaves as a wave. So we have already gone through. Now, photoelectric effect is the most interesting fact actually. You know why photoelectric effect is being done? Because at that time they wanted to further prove it that really a light is a wave. But when the results came up, they found out that light is not a wave because the results are totally opposite of that. Once we come to that, then I will let you know what will be the results and what were the expected results. But the results were totally different. So in photoelectric effect, the electrons and photons exhibit the properties of a particle just like a blind ball. But you surely remember that diffraction experiment and interference fringes, just like how two ripples of the surface of the pond interact. Now, see the de Broglie equation. They say that de Broglie hypothesis stated that there is a symmetry in a nature and that if light and radiation behave as both particle and wave, matter 2 will have both particle and wave nature. Now, this is very interesting fact. They say that as the wave got two natures, matter got two natures as well. It means that even we are as a human, we got two nature as well. We have a body as well, and we actually have a wave as well. We got waves associated with us as well, which can be given by h is equal to lambda is equal to h upon p. Or what is p? P is called the momentum. You know the same momentum we have studied, which is equal to mass into velocity, where h is the Planck's constant. So through de Broglie relationship, we now had a wave theory of a matter. The lambda has representing the wave of a particle and p represent the momentum of a particle. Here h is a Planck's constant, m is a mass and v is the velocity of a particle. The significance of the de Broglie relation is that it proves mathematically that matter can behave as a wave. In layman's term, the de Broglie equation says that every moving particle, microscopic or macroscopic, has its own wavelength. Now, this is very interesting. Actually, this is the start of quantum physics, technically speaking, because H is a part of a quantum. So initially, that was H is actually behaving as a Planck's constant. Then later on, Einstein actually tells us that light is not actually a wave anymore. I will let you know. So what de Broglie is saying, de Broglie equation says that light is particle as well as wave at the same time. And he is just saying it that every single object, whether a big or a small or whatever it has a wave associated. It means you, me, and every one of us, we have a wave associated with us, right? So that wave is very simple. You can find out the formula by using lambda is equal to h upon p, where h is a Planck's constant and p is the momentum. If you have a Planck's constant and you are running with a certain velocity, you can find out your wavelength. Okay. So that is what it is. So microscopic object, the wave nature of a matter is observable. Now this is very interesting. The wave nature of a very big object is actually not observable because it's a very big object. For a large object, the wavelength gets smaller with the increased size of an object, quickly becomes so small as to become unnoticeable, which is why macroscopic objects in real life do not show wave-like properties. Even the cricket ball you throw has a wavelength that is too small to you can observe. The wavelength and the momentum in the equation are connected by Planck's constant. Girls, any issues in this? De Broglie wave?
No. Can you remind me what is Planck's constant?
Planck constant, I didn't tell you for the time being. Just remember that Planck's constant is a formula actually, which we will inshallah be working on. We can do that E is equal to HF. A Planck's actually give you can say a frequency which is originated from somewhere. He said that the energy along with the frequency can be found out by simply E is equal to Planck's constant. What he said is energy is directly proportional to the frequency. So whatever the energy we have it from one wave, it is directly proportional to the frequency of that wave. So it means that if frequency increases, energy increases. Okay. So he said energy increases with the frequency. On the other hand, the other scientist said that intensity increasing with the amplitude. Mostly he said with the amplitude. That is, we are talking about for the time being, we are talking about the wave nature of an object. We didn't talk anything about the quantum effect, but we are very near to become, jumping into the quantum effect from here. But initially, at this point, we are talking about de Broglie equation, and the above equation is called as Planck's equation, which says energy is directly proportional to the frequency of the wave. So it can be given as E is equal to HF, where H is the Planck's constant and it has a specific value which we will be talking about. Girls, just go through it and tell me if there is any problem. Let me know because the topic is a bit like tricky and a new one for you. I mean, you never heard this before, I believe. So can be a tricky one. So go through that. Alicia, Manur, Zoha, any question, please ask.
So far, it's okay.
What about you, Alicia
Yeah,
and Mano?
nothing for now. Nothing for now.
So why does the wave why is it difficult to observe with macroscopic objects?
The reason is if it's a macroscopic, the momentum will be higher, right? Like for example, if it's there is a truck here. Let's suppose you got a truck here. Now think about it. You got a truck here whose mass is, let's suppose, 1,000 tons. How much mass it will be? 1,000 multiplied by how much is 1 ton equal to? Let's take it as 1,000 ton, 1,000 kg. Let's so, and let's suppose if it's that truck is moving with 60 meter per second speed. So, what will be the total momentum? It will be 60,000 altogether. Now, if this momentum actually increases, the lambda will be reduced. So, technically, for a very macroscopic level, the big object, the momentum will be too much higher and higher and higher and higher because the masses are very big. Like if you are running, your mass, not yours, my mass will be nearly 100 kg. So if I am running with a speed of, let's suppose, 5 meter per second, so it will be 100 multiplied by 5 will be 500. If some person having 150 kg and he is running with 5 meter per second, his momentum will be, again, hello?
Wait for me.
So basically, if the momentum is increasing as per the formula, the lambda will be reducing. Momentum will be reducing. Lambda will be increasing. If momentum will be increasing, lambda will be reducing. Right. So by any chance, if the object is very small one, that his mass is very small, then actually momentum will be goes reducing. If momentum will be goes reducing, the lambda will be more and more visible and bigger value. So in that way, it will be more and more visible and noticeable. Otherwise, your lambda may be in nanos or maybe in 10 raised to the power minus 12, so that it cannot be observed. Understood?
Yes.
Okay. So I think we better stop it here today till de Broglie equations, and we will proceed from here. Okay. Now, one more thing. We'll have our fifth class on Sunday. What time is suitable for you? 8 or
Uh,
I have a class at 9 o'clock. Can that be 8 p.m. PST?
Wait, can it be any earlier, like during the day?
Earlier. Let me just show you my timetable here. You will select on your own because it's only for the, till Eid and this only 1 week left anyway. So, yeah, this is my timetable for the Sunday one. I'm talking about this one. So, which one is suitable? You tell me. If you can take a class at this point, you can have it. What about at class at uh, class at 4 o'clock p.m. PST? Will that be available? I mean, will that be easy? If you are not going to school,
Yeah.
what about
Yeah,
other
4.
Yeah, fine.
Manur and other? I mean,
Four is fine.
So
Four.
4
Yeah.
Pakistani time, right?
that time, 4 o'clock,
It's three for
4 or 5. Yeah,
Okay.
it's 4 o'clock. Only for this Sunday
Okay.
and the next Sunday only. Because afterwards, if there will be Eid, and after Eid, the timetable will be the reverse one, the old one previous. So only for this Sunday and the next one. All right.
So, sir, we'll have classes on Sunday, Monday, Thursday, Friday.
So it will be for the time being, it will be today, that is Thursday, Friday, Saturday, Sunday, and Monday. Right?
Okay.
5 classes altogether. So next okay. So this Sunday there will be a class. All right. So we will have a class at 4 p.m. PST. Remember that I'm talking about PST. Please don't be confused between PST and your time, because some people are confused between their time and my time. All right. So it's my time, not your time. All right. So time will be 4 p.m. What is the time at your place?
It's 3.
3. So 3
Three.
o'clock on Sunday. But tomorrow, as usual, we have a class at the same
Yeah.
slot, which is 11. So let's have a class at tomorrow and then day after tomorrow. And on Sunday, it will be at uh, 3 o'clock at your time or 4 o'clock at my time. This Sunday and the next Sunday. right? And afterwards, we will see to it. Our normal routine time will be 4 classes with Mahanur at 11 o'clock. But afterwards, definitely, we will have 5 classes then, and we will see what time is suitable for that. And Alicia, your concept is clear regarding the question you have asked. You know that question you
Oh
have
yeah,
asked.
yeah, understood that.
The
Understood.
value, why the value is different? The reason is very simple. The method you have chosen is a different or direct method, and the value I have chosen is a long method and a more precise method. That's the reason you will have a difference of about zero point 0.5, zero point 0.6. But what
Okay.
method is suitable for you? I tell you, always select the longer method. Longer method will always be easier. Okay.
Okay.
Okay. See you inshallah tomorrow then at same time. Okay. Bye.